Hey everybody, good to see you back once again. So yeah, as forecast, it is still raining outside, so we're just handling a bunch of rainy day projects in the shop here again today. We'll just jump right into it. One of them that I've been saving for a while was initiated by a comment left by Line Shaft Restorations several episodes back when I was doing like the refurb on the fuel tank cap and everything else. And I mentioned that I was going to have to make a new fuel level dipstick for 5J1113 because the one that it had in the tank was pitted beyond being legible in some areas. And he was wondering if there was a published drawing anywhere showing where the different tick marks were in relation to the gallons that are in the tank. He said that his seed tank on his D2 just had a brass rod with evenly spaced marks, and being such an irregularly shaped tank, he was very doubtful that it was accurate at all. So follow me to the bench. So here's the full breakdown right here. Just to refresh everyone's memory, this was the extremely pitted fuel tank dipstick out of the D2 that I'm currently rebuilding. And to use as a pattern, I pulled a dipstick out of another fuel tank that was still fully legible. So to further verify, setting them both side by side, 3s line up, 6s, 9s, there's the 15, so on and so forth. So using the legible dipstick, I made this one right here. This is, of course, the seat tank version. I've also got a couple of fender tank D2s around here that had good sticks in them, so I pulled the best one out of there. Fender tank right there. We have complete specs for that too. Now, one thing I added in the corner down here because I neglected to do it the first time around, and I think it's an important disclaimer, both of these dipsticks are for the 20-gallon fuel tanks that were found on all of the 3J and 5J series D2s. And when we get into the U series, they were also found on D2s 4U1 to 4U6372 and 5U1 to 5U13236. After that serial number break right there, which happened in mid-1953 model year, from 4U6373 to into production and 5U13237 to into production, they increased the size of the fuel tank. These are what's known as the later series D2 tractors right here. They upped it to 26 gallons. Like I said, mid-53 to 57, which was into production. So these dipsticks are not going to be applicable to later tractors in that serial number range right there, but it covers everything that came before that. Now that we've got all that lawyer talk out of the way, so they're made out of the same steel, 5/16 of an inch wide, 50 thousandths thick. And what I did here was we'll start with the seat tank dipstick because it's such an irregularly shaped tank. It's quite a long stick. So overall length from this end, we go all the way up to where the 90-degree bend is. We're looking at 23 3/8 of an inch overall length. And we have the tab, or the tang, the little handle part right here on the end, that's 7/8 of an inch right there. So that being said, we start down here at the very end, and of course we have the first 3-gallon mark at 3/4 of an inch. Again, we're measuring from the end, so 3/4 up is 3 gallons, 6 gallons is 2 1/8, 9 gallons is 3 11/16, 12 gallons is 8 1/8 inches, 15 gallons is 12 11/16 inches, 18 gallons is 17 3/8, and finally the 20-gallon mark is at 22 1/8 inches. And because the fender tanks are more regularly shaped, the different increments are spaced a lot more evenly. So again, overall length of that fender tank stick is 13 inches. And we have our handle on the end. That's a full 2 inches right there because that's got a larger filler neck on it. So that's a little bit more to grab onto. So once again, starting from the end, we have our first 3-gallon mark at 1 3/8. 6 gallons is at 3 1/8. 9 gallons is at 4 7/8. 12 gallons is at 6 5/8, 15 gallons at 8 3/8, 18 gallons at 10 1/2, and 20 gallons right on the 12-inch mark. And looking at the stampings that I put into my stick, of course, I don't have the exact same size and font as the Caterpillar number stamps. Surprisingly, that really doesn't bother me. I just wanted to have a dipstick that was accurate and legible, and thankfully, my number stamps just barely fit onto that flat steel. So it'll work just fine for 1113. All right, next up today, we're going to start looking at gauges a little bit. Here's the oil pressure gauge that's original to 5J1113, and it's not in great shape. I think you can see all of that rust migrating around in there, yeah, it's pretty rough. So this is the old Sylphin gauge. Now when I say Sylphin, I'll show you an example. I had a really good original Sylphin fuel pressure gauge that I've already put on. This gauge was not original to this tractor, but this is the correct and proper style gauge for this vintage of Caterpillar. This one was just already in usable condition. I cleaned it up a little bit. Still has a decent needle. You can read the face. It works. Pop that on the fuel tower. We were good to go with minimal effort there. The oil pressure gauge, however, we're not so lucky. So thankfully these do come apart relatively easily. There's not a whole lot to them. And the Antique Caterpillar Machinery Owners Club, or ACMOC, sells new gauge face kits for not only these old Sylphin gauges. Here's the one that is applicable to this oil pressure gauge right here. It says lube oil pressure with the operating range. We have the Sylphin logo on the bottom. Comes with new screws that holds the gauge face onto the main body. Instructions as well as tools for pressing the bezel and everything back together. They also have, here's a couple of other examples. They sell the gauge face kits for the older US gauges. This is an oil pressure gauge. It would be used on the older gasoline powered cats. And here is a Sylphin fuel pressure gauge face kit. Pretty much the same contents in each one. So just out of curiosity, I do want to test this gauge before we take it apart. See if it even works. So I just usually air pressure test these. I've got my vacuum / pressure tester here hooked up. And we'll start dialing up. There's 10 PSI. Needle has not moved. Let's dial it up a little bit. We're 15 PSI. That needle's stuck. I'm saying the gauge is completely seized up. So we have our work cut out for us. First thing to do is remove the glass face and the bezel. The bezel is just a friction fit in here. There's a seal down beneath it, and they pry up rather easily, but just be careful because you can bend them and dent them rather easily. So just work it up little by little all the way around till it's free. There we go. Not much of the old seals. Getting pretty crispy. Let's dump all the debris out. Oh man. That thing was full. Wow. Didn't expect that much. All right, flipping it over. Working from the back side, we can take these two screws out. They hold the inner workings of the gauge to the housing. That thing should have just fallen out. There we go. Oh, yeah, it's about as bad as I expected it. Yeah, and with that, look at the old face is just crumbling. There's just nothing left of it. Man, this thing got rusty. There is a cork gasket on the back side of it, meant to keep a lot of moisture out, but it's a little bit deteriorated now. Looking at everything else, I'm betting the reason why it's stuck is because the plunger that's down here is very likely stuck in the body. When they get this bad, it's pretty tough to salvage them. You can, but I have a lot better ones around. Yeah, just by looking at this, I'm pretty much ready to write it off. But good news is, I've got more. This is another Sylphin, right, correct, and proper for this vintage of tractor. So we're going to start dialing up some pressure on it. We'll just watch the needle. We're going to do a function test. I saw it jump. Oh yeah, needle's moving. We have a functioning gauge. So that is a good first step right there. So we'll just disassemble this one. It's the same way we did the other one. So glass bezel comes off. Then we'll remove the screws on the back. And look at that, it's already starting to fall away. That's how it should work. And we can carefully, a lot cleaner in there. I'm liking that. There's our cork seal, still intact. Yeah, that's a much nicer looking mechanism on the inside. Now we'll carefully position it in the vise. Don't want to break anything at this point. And with a properly sized screwdriver, nice and sharp, we will loosen the face screws, take them completely out. And now we pivot the face. We have the little peg right there that's the needle stop, so we want to rotate that away from the needle. And we're going to line the cutout, that arched shape cutout in the bottom, with the shaft of the needle, and just carefully take it off, just like that. And it's just a short time later. You can see I've got everything cleaned up. All the old paint is off of the gauge housing, as well as the brass bezel ring for the glass. I love, it's so much brass in these things. I just love the way they made stuff back then. Here's the old face. You can see once again, that's brass as well. The peeling paint on the front reveals that. I also took this opportunity to apply some fresh white paint to the needle for the gauge. That's a flat white. I prefer flat over gloss because it better matches the flat white that's on the new replacement gauge face. And of course, there's the tools, the gauge face, and the new screws, should we need them. I don't think we're going to need those because the original ones are just pristine yet, so I'm probably just going to use the original ones over again, save those for some spares. This is also the perfect time to explain how these old Silfin gauges work. This is an old Silfin fuel pressure gauge. It's the same mechanism as the oil pressure gauge, just set to a little bit different pressure range. And interesting fact, the word Silfin, well, that's just an old word for a bellows or a compressible bellows, and that's what these gauges are. We'll show with this one. Okay, this is one, it was leaking fuel, so I basically sweated it apart. They're just soldered together. So first thing that comes off the top is this retention disc, and beneath that is a bellows. Okay, and then you're left with an empty housing. So you can see it compresses, and when it compresses, the rod, the center rod, comes out of the top of it. Really simple the way they work. So the fuel or the oil comes in the back here through the port and comes into the chamber on the inside, surrounds this bellows, and as the pressure increases, it just compresses the bellows. The bellows compress, and that center rod moves up the top. The rod, of course, is attached to this copper wire. The copper wire acts upon the needle, and that's what moves the needle of the gauge. So simple, it's just crazy. And the way they calibrate these, in this top disc, you can see this center sleeve, hopefully you can see, is threaded. And that's basically just a stop, because you look down, the base of that rod down there has a shoulder on it. So that's just an adjustable stop that allows that shoulder to hit it at different points to calibrate the needle sweep of the gauge. And maybe you can see, get something to point with. Yeah, on this side over here, you can see little staking marks. One right there, one right there. I know GoPros are awesome for close-ups, but yeah, once they got that calibrated, they staked that threaded sleeve in place so that it couldn't move, and that's your whole gauge. Simple as that. And to see it all in action, once again, we're going to introduce some air pressure to the inlet port back there, and watch the rod right here. It's going to start rising up out of that threaded sleeve as we dial the pressure up. So see the needles moving? We're compressing the bellows inside. That's pushing on the rod. The rod is acting on that copper wire that is acting upon the needle. So let the pressure off, return it down to 0. It's just so simple, yet so effective. Really interesting the way they figured all that out. So the only thing I'm going to do for maintenance, being that this is a functioning gauge, it shows no sign of leakage, I'm going to make sure that the rod is oiled where it goes in and out of that threaded sleeve. Also, we're going to apply some new oil to the pivot for the needle. That's pretty much it. Now that we know how the whole thing works, we've got the new replacement gauge face, so it's time to put it all back together. So we'll carefully guide the needle through it. There we are. Being careful not to scratch anything. Rotate it around into position. Attach it. Once again, I'm using the old screws over because these were still pristine. Do a quick check, make sure the needle's not binding on the stop tab. Oh, looks good. Next, I made the new cork gasket for the back. There, that's securely in place. So now we will reinstall all of the guts into the housing. Just hand starting the screws for now, just to hold everything in alignment. Here we are. Gauge face in the housing. So next is the glass with the bezel. These had, some of them have like a little rubber seal. Others have had like a small diameter cork ring. That stuff's usually always just deteriorated and gone. I've got some of these O-rings in like a miscellaneous selection. Some of these were left over from my automatic transmission rebuild days. And I just find one that will fit around the back side of the bezel ring like that. That's usually all you need to seal that against the housing. So the glass and bezel, once again, is just a press fit into the housing, and that's where the PVC tools come into play that are in the kit. So you've got this one that acts like as a backup ring, and then this is chamfered around the inside diameter to go around the bezel ring, and you can put these in an arbor press, press them together. If it's a light press fit on the bezel ring, you can just, I've gently tapped those with a mallet before, but that's basically how you seat that glass and bezel ring without damaging the glass or the gauge face. So we'll get that seated real quick. This is just how I'm doing this because this bezel did not come out very hard before. I think it just needs a little bit of help with a mallet. I would recommend using an arbor press though, especially if you're at all nervous about it. Okay, we're seated down well around, or against the O-ring all the way around, so we should have a well-sealed gauge. As much as this may shock you all, there's one more step to this process that I'm going to do. All right, it is the next day because we had to wait for some paint to dry. Just peeling off the last of the masking. And yeah, I did this to represent how far you could go with repro parts and otherwise good pieces. And this is a fully functional gauge. Needle has been repainted to match the new face. Exterior has received a fresh coat of Caterpillar yellow. It's all sealed up. It's been tested, been verified. But I know what you're thinking. This isn't going to be a good match for 5J1113, and that's the truth. So I'll get set up there. I'll bring in another one. So this is the one right here that I've fixed up for 5J1113. It has the glass and the bezel from the original that was just beyond saving, or beyond practicality in this case. So I just threw that on a good housing that I had, and I have a good working gauge on the inside with an original face, just the perfect amount of patina on the inside. And of course I gave it the whole Squatch 253 weathered paint treatment, where we have some shades of yellow, some shades of brown, some replicated nicks and dings, and that's just going to be perfect for 5J1113. It's going to blend in with everything just fine. I had a piece of glass that was not chipped, not cracked, but has just enough little scars and scuffs in it. It just lends further credibility to an intact finished machine. So there's our lineup. And as long as we're on the topic of these oil pressure gauges, so these are just the operating range, basically go, no-go display gauges. They don't give you numbers that tells you exactly what the oil pressure is that they are registering. And a lot of people will ask, well, what are these showing then for pressure? These are 10 psi to 40 psi calibrated gauges. That's what these old Sylphans are, because 30 psi is the stated oil pressure spec in the manual for the Cat D2, many other models of this era as well. So as long as you're in the operating range, you know, you've got a good to go engine. But Cat later found that these engines oftentimes ran on much less than the minimum 10 psi that it took to get that needle into that white operating range zone. That's where this service bulletin scan that I have comes into play. Now this is from, I would say, mid-model year 1950, so well after the D3400 run in the J Series D2s. We were up into the D311 range in the U Series D2s by the time this came out. And they found, to put it in a nutshell, well, during the design and development of all Caterpillar diesel engines, tests have been run to determine the minimum amount of oil necessary to lubricate all the moving parts at all speeds, high idle, full load, and low idle. In every instance, the lubricating oil pump delivers more than adequate volume of oil to all the moving parts. However, because of the very low resistance to oil flow through the bearings at low idling speeds, the pressure of the flowing oil may be as low as 4 to 5 psi. So the problem they were having with these older 10 psi to 40 psi calibrated gauges was, after a machine got a certain amount of hours on it and the operator had it up to temp, threw it down to low idle, they would notice that their needle would start drifting down below operating range on the gauge, and understandably they would become concerned. So they were having so many reports of that issue happening, and Cat had, like it says here, since learned that these can idle at 4 to 5 psi and be just fine. They retooled, recalibrated the oil pressure gauges. So the old ones took 0 to 10 psi to be below operating range and 10 to 40 to be in operating range. They just came out with a gauge that registered at lower pressures. So the new gauges were 0 to 4 psi was below operating range, and then 4 to 11 is all that it took to put it in the operating range or even peg the needle out to the max. And I've said this before, but it bears repeating once again. That service bulletin proves what I've said about the oiling systems on these early Cat diesels. They're such a high volume system that even at 4 to 5 psi, everything's still being lubricated just fine. I mean, we're supplying bearings that are like that wide and that big around throughout this whole engine. And this is just a little one, okay? This service bulletin is applicable from D2 tractor all the way up on through D8, all the motor graders, all the industrial and genset engines, even up to the great big D17000 industrial and genset V8s of the day. And that's also why when I was testing these gauges with the air pressure, I was only dialing it up to about 10 to 15 psi, and I verified that it ran the needle up to the beginning of the operating range on each one of them. So we could have went higher, but the low end is where I wanted to verify both of these because that's where it counts, being that I test ran this D3400 with all of the mechanical test gauges on it. I know for a fact we're running 30 psi oil pressure on this pretty much at all times. So when I put this gauge on there, I'm going to expect the needle to be about center to maybe the upper 3/4 of the operating range. Everything should be good. So that should do it for oil pressure gauges. We still have coolant temp gauge left. This is the original cat gauge from 1113. This is all we've got of it. This is all we had right here. And from the rust that's rattling around in that, I don't expect it to be much better than the oil pressure gauge was. But I've got quite a challenge ahead of me with this. That's all right, though. We're not getting into that today. As you can see, we're not exactly wearing the Sunday best. It's, well, nice weather has returned, so it's time to finish that stack of track pads outside. We'll be welding and grinding and blasting rust and doing everything else today, so we're ready to jump into that right now. I want to get rolling on that, finish that part of the job, because it's not very much fun. So, all right, that concludes the rainy day projects. Back into production mode. Thanks for watching as always, everybody. Hope to see you back again.